Hello everyone, welcome back. Now let us start problem number 34, which is on page number 518 of Griffiths Electrodynamics chapter number 12. So this problem says a neutral pion of mass m, momentum 3 by 4 mc decays into two photons. As you know that photons are restless particles or massless particles, sorry. Photons are massless particles and their rest mass is 0. I hope you know that. One of the photons is emitted in the same direction as in the pion. All right, so this is pion and two photons are one in the same direction and other in the opposite direction. This photon 1, this is photon number 2. All right, find the energy of each photon. We need to find the energy first of all. So let us write the uh, momentum first of all. Momentum, it is given by 3 by 4 mc and it is at rest, so 0. And for this momentum it is going in this direction, so I'll be using uh, minus here, and for this I'll be using this is the momentum for massless particles. I hope you know that. And other is p2, with it is going in plus direction, so I'll be using plus. This is the magnitude. All right, this one is the magnitude of p2. So now, right, as from momentum conservation, we can write it as and for massless particles, we very well know that. Sorry, for massless particles, we very well know that E is equal to Pc. For massless particles, we have the formula, so we can directly put the values here in this two in terms of E1 and E2, and we can generate an equation which is minus E1 plus E2. It is equal to 3 by 4 mc square. Why mc square? Because one c from here, and it will be in the divide section and in denominator section, and will go in the right hand side. That is why. So this is our first equation. Now from momentum we'll find the energy relation also. As you know that E square is equal to p square c square plus m square c raised to power 4. P square is given by 3 by 4 mc, so 9 by 16 m square c raised to power 4 plus m square c 4. It is 5 by 4 mc square. E. All right, value of E. So by we have calculated the energy now, and simply we know that energy for both the photons will be, suppose it is E1, but we do not have, will be having the negative sign in the energy now. Why? Because for total energy, if we write, what will we write? 5 by 4 mc square comma 0 at its rest, and this for E1 and comma, sorry, this is E1, this is E, this is the magnitude of E1. Similarly for E2 also, it must be having some energy. And from energy conservation, 5 by 4 mc square is equal to E1 plus E2. This can be the second equation, because energy conservation should be there and momentum conservation. You need not to apply these. You can simply say that from momentum conservation we can use this is equal to this plus this, and simply put P1 and P2 as E1 and E2. Now simply again for energy conservation, that energy for first photon for second photon is equal to the energy for pion. So on solving these two equations, what we'll get, 2E2 is equal to 8 by 4 mc square. So E2 comes out to be mc square simply, and E1 from this equation, if E2 is this 5 by 4 mc square minus mc square, it is E1 is equal to 1 by 4 mc square. All right, so this is the value of E1 and this is the value of E2 if you use this coordinate. So that's all for this video. See you in next video. Bye bye. Thank you.